Hello guys, what's up? Saion this side, and today I'm here with you with a mind-blowing question. This small question that you see on your screen is like a crazy question, guys. Like हालत टाइट हो जाएगी इस क्वेश्चन को सॉल्व करने में. It's that crazy. So let's get started with it because this is going to be like kind of tough to understand. You should try this first yourself and then you should go on to the solution. Many of the solutions that I've seen online, they are using like the concept of vectors and all of that, and they must be good. I haven't studied vectors yet, but that's not intuitive, right? When you are in an exam, what you're thinking is making cases. You're not thinking about vectors, right? So I'm here with my intuitive solution, right? And here you go. Let's start. And I think this is one of the better solutions, but you are the judge of that. Okay. So the question says, how many 3 cross 3 matrices exist made up of only 1 or minus 1 such that the determinant of the matrix that we make is not equal to 0. So basically we are using just 1 or minus 1 in our matrix such, and we want to find such matrices, the like number of matrices where the determinant is not 0. Okay, that's the question. Pretty simple to understand, but the question is pretty complex. Okay, so let's get started. uh, Here's our matrix. Now let's find how many total matrices will be there. Each spot has two choices, right? Each spot has two choices, so there will be total of 2 to the power 9 matrices. Here there's no condition on the determinant. There are total 2 to the power 9 matrices, right? And 2 to the power 9 is 512. Okay, so we should note this down that the total number of matrices are 512. Okay, we'll in the end subtract the matrices whose determinant is 0 from 512. Okay. Okay, so let's keep 512 in a corner over here. Okay, so now our matrix is filled with ones or minus ones, right? Now when is the determinant of a matrix 0? Let's think. When two rows are same or proportional, right? When two rows are same or proportional, then we say that the determinant of that matrix is 0. So for example, if we have 1 1 1 1 1 1 minus 1 1 1, so these two rows are same and hence the determinant of this matrix is 0. Okay, similarly the proportional case also exists. So if two rows are proportional, then also the determinant of the matrix is 0. So let's say 1 minus 1 1 and minus 1 1 minus 1, right? So as we can see, minus 1 comes out common from the second row. When we take minus 1 out, then the two rows are the same and hence the determinant is 0. Okay, so there are two cases: when the two rows are exactly same, or when one of the rows is negative of the other row, right? Then the determinant of the matrix that we form is 0, right? So what our aim is right now, to find the number of matrices whose determinant is 0, and in the end we are just going to subtract from 512 to get our final answer. Okay, so let's see. Let's say 3C2. Let's choose two rows out of the 3 that are there. Okay, and let's focus on the cases where the two rows have exactly same values. Okay, so the number of ways a row can be formed is 2 cube, right? That is 8 ways a row can be formed. So let's say the first row was 1 minus 1 1, then the second row also has to be 1 minus 1 1. So 3C2 into 8, there are 8 ways to form a row, and the second row there is only one way to form the second row. So forming the first row there are 8 ways, forming the second row there is one way because it's the same as the first row, and we are choosing 2 rows out of the 3. Now What do we do for the third row? The third row that is left, what do we do for that? Okay, let's what we should do, is let's keep the third row different from both the rows. Why should we keep it different from both the rows? If it is same, then there is a possibility of double counting. How there is a possibility of double counting? In fact, not a possibility, but there will be double counting. How? Let me show you. So for example, we choose the 3c2. From 3c2 we choose the first two rows. Okay, the first two rows are 1 minus 1 1 and 1 minus 1 1. Okay, and let's say we permit that the third row can be same as the above two rows. So let's say the third row also becomes 1 minus 1 1. Okay, then in the next case we choose these two rows. They become 1 minus 1 1 1 minus 1 1, but then this row can also become 1 minus 1 1. And similarly, if we choose these two rows, then also the double counting will be there. So we are counting this whole matrix 3 times, right? And we do not want to do that. So we are going to say that we choose two rows out of 3. We create one row. The second row is the same as the above row, the previous row, and then for the last row there are 7 cases. One case is excluded, and that case is whatever the arrangement was for the above two rows. So if the above two rows were 1 minus 1 and 1, then the third row cannot be 1 minus 1 1. It will be something like 1 1 1 or something else. Okay, so this is the number of like cases where the two rows are same of the matrix and one row is different, and that matrix's determinant will be 0. Okay, so two rows are same, one row is different. These are the total number of cases: 3c2 into 8 into 1 into 7. So 3c2, sorry about that, 3c2 into 8 into 7. These are the number of cases where two rows same, one different. Okay, two rows will be same in this, one will be different in this. Okay, now what we have to do, we have to add the cases where one row is the negative of the other, right? We have to add the cases where one row is the negative of the other, and then we are going to settle the third row. Okay, what's the case where one row is negative of the other, and then we are going to settle the next case. Okay, so we are going to choose 8 ways to create the first row, and then the second row will be the negative of the first row. So times 1 times what we are going to do, we are going to do times 6. Why times 6? Why exactly times 6? So what we are doing is, we are here in times 6 we are excluding two cases. The first case that we are excluding is when so let's say 1 minus 1 and 1 is the first row. So minus 1 1 minus 1 1 and minus 1 will be the second row. So what we are excluding is, we are excluding that the third row cannot be this row and the third row cannot be this row, right? So the third row cannot be 1 minus 1 1, the third row cannot be minus 1 1 minus 1. So that's why we did times 6. Why cannot be the third row be like 1 minus 1 1? Because that case has already been counted in the two rows same case. Let me show you. First row is 1 comma minus 1 comma 1, second row is minus 1 comma 1 comma minus 1, and if we say the third row is the same as the first row, 1 comma minus 1 comma 1, this case has already been counted in the two rows same case, right? In this case over here, the two rows same case has already counted this case, so we will be double counting if we allow this value or this value as the third row. Okay, so there are only 6 possible cases for the third row, and in this case one row we are creating, the other row is the negative of the first row, and then the third row is different from both these rows. Okay, so now here what was happening, here there were like two rows same, one row different. Here uh, two rows, one row is negative of the other, and the third row is not the same as both of them. Now we have not just considered one case, that is when all three rows will be same, and there are 8 such cases. Why? We can form one row with 2 cube base in 2 cube base, and the other rows are have 1 option, right? So 2 cube into 1, that is 8, right? So let's solve this. I hope you understood what we are doing over here. Let's solve this. 3 into 8 we can take common, so 24 is common, and times 13, 6 plus 7, 13 plus 8, right? So 24 into 13 we can say 240, 288, 288 plus 24, 298, 308, 312, 312 plus 8, that is equal to 320, and 512 minus 320 equals to 192. So these are the non-zero matrices that are there. I feel this solution is the best solution for this question, right? And I hope you understood what we are doing over here. It's a bit complicated. You'll have to think this through 2-3 times, and slowly I think you'll get the hang of it. If you just rewind and hear what the explanation is, I'm sure you'll get the hang of it. But this was my solution, guys. If you find any error in the solution, or you find a better solution, because I didn't understand those vector solutions and all, so if you find a better solution, please let me know in the comments, and I'll see you in the next one, guys. Thank you. Okay, I'm recording this part later. Many of you might have the doubt in this 2 rows same, 1 row different. Many of you might say that there's the case of double counting, like for example 1 1 1 1 1 1 and minus 1 minus 1 minus 1, right? 2 rows same, 1 row different, right? So you might say this is double counting, but no, this is not double counting. Why? Because in the negative case, 3c2 into 8 into 6, when one row is the negative of the other, then we constrain the third row to not be the same as the first row or the third row in this case, right? So in the negative case, when one row was negative of the other, this case was not included. This case was included in the 2 rows same, right? This case wasn't included in the 1 row negative of the other, right? So like you might think that there is double counting going on over here, where one row is the negative of the other row in the 2 rows same, 1 row different case, right? But that's not true, because this case wasn't included in the 1 row negative of the other case, right? If you get what I'm trying to say. Just wanted to add this note, because many of you might have the doubt. While recording the video, I also thought, isn't this double counting? But no, it isn't, because like when I like thought about it, this case hasn't been included in this case over here, right? So this was just a note. Thank you for watching.